Hi, this is Mrs. Perillo, and in today's lesson we're going to be looking at solving trigonometric equations. In these problems, we'll be looking to figure out what value of x, or theta, we would need to satisfy the equation. So we'll be finding angle measurements. In example 1, we're going to solve 4 cosine squared x equals 1, and you'll notice that it asks us to find all solutions from 0 to 2 pi. This means that we'll be working with radians. Now, when working with trigonometric equations, we're going to use some of the same strategies we might use with other types of equations. So here we're going to work towards isolating our cosine x. So first we'll divide by 4, which leaves us with cosine squared x equals 1/4. And we know when we have a squared term, it makes sense to square root it. So we're going to square root both sides of this equation, which will give us cosine x equals positive or negative 1/2. So our goal is to figure out what value of x, which remember is representing an angle measurement, would satisfy this equation. So we really have two things we're trying to solve. We're trying to figure out what value of x would have a cosine of positive 1/2 and what value of x would have a cosine of negative 1/2. This is where our unit circle becomes very helpful. On our unit circle, remember all of the y coordinates represent, all of the x coordinates represent our cosine values. So we can figure out where do we see x coordinates of 1/2 and negative 1/2. So I've gone ahead and highlighted all of the values of x that are 1/2 and negative 1/2, which represents the cosine values. And along with that, in green, I've highlighted the radian angle measurements that go with that. So those green highlighted measurements would be our 4 angles that happen to satisfy these equations. So for positive 1/2, I see that my angle measurements could either be pi over 3 or 5 pi over 3, since that's where cosine is positive. And then for negative 1/2, I see my angles could be 2 pi over 3 and 4 pi over 3. So we have 4 different angles that satisfy this. And we do want to list all of these solutions because it asks us to find all solutions from 0 to 2 pi. So you can see how helpful it is to have the unit circle when working through trigonometric equations. In our next problem, we're going to solve a trigonometric equation involving tangent. Before we get started, I want to make sure you are aware of how you would find tangent using your unit circle, since it's not directly on there. So hopefully you remember from things we've learned previously that tangent is the same as sine over cosine, or the same as y over x if we're talking about points on the unit circle. That means anywhere around the unit circle, if you take the y coordinate divided by the x coordinate, that would give you your tangent value for that angle. So as an example, if we look in our first quadrant at pi over 6 or 30 degrees, if I take root 3 over 2 divided by 1/2, and I simplify that down, that would end up becoming root 3 over 3. Which means my tangent value at pi over 6 is root 3 over 3. You might find it helpful to go around your unit circle and write in all of your tangent values by dividing the y coordinate by the x coordinate so that you have them available when solving any equations involving tangent. If you want to pause now and try doing that, you can. I'll fill in mine as well. So as you can see around my unit circle, in red, I've written all of the tangent values for each angle. This will help us as we go through to solve this equation. So we're solving an equation involving tangent. We're going to approach the problem similar to the last one, where our first goal is to isolate tangent of x. So I'm going to go ahead and use my normal algebraic steps, subtracting 1, and then dividing by root 3. Which gives me that tangent of x equals negative 1 over root 3. Now, since I've already gone through and filled in all of my tangent values around my unit circle and they're all rationalized, it's going to make sense for me to rationalize this value for tangent of x before I try to find it on my unit circle. So I'm going to go ahead and multiply by root 3 over root 3 so that I find out that I'm actually looking for a value where tangent of x is equal to negative root 3 over 3. Now looking at my unit circle, I see that there are two spots where I have a tangent value of negative root 3 over 3. One of them is in the second quadrant and one of them is in the fourth, which actually makes sense if you remember when we learned about all students take calculus as a way to figure out which trig functions are positive in which quadrants. That told us that tangent was positive in the first and the third, and we're looking for a negative value of tangent. So we would expect it to be in the second and fourth quadrant, and we can pull the angles from here. Now notice also in these directions, it was different than last time. It asked us to find all solutions from 0 to 360. So that tells us that we're working in degrees this time and not radians. So I represent these angle measurements as degrees. So in the second quadrant, I have a 150 degree angle. And in the fourth quadrant, I have a 330 degree angle. And so those would be my two solutions to this trig equation. Our third example is probably the trickiest, both for solving and finding our values on the unit circle. So I'm going to go ahead and copy this down, and you'll notice that we actually have a cosine squared term and a cosine term in this problem, which if you think about that, it mimics a quadratic equation like we might have seen in the past where we have a squared term and a non-squared term. So if you thought of this as 8x squared minus 2x equals 1, so I replaced the cosines with x's, you can see how it looks just like a quadratic equation, and that if we were trying to solve this as a regular quadratic equation, we would probably try to factor it. So we're going to take the same approach here, except using cosines instead of x's. So if I'm looking to factor this, a logical first step would be to get it equal to 0. So I'll subtract that over. And I am using either split the middle or guess and check for this type of factoring because I have that 8 in the front. And so it's going to be 4 cosine theta plus 1 and 2 cosine theta minus 1. And again, I just used either guess and check or split the middle for that. You can always FOIL it back out to check it. And then once it's factored, remember, I can use the zero product property. So I know that each one of these factors can be set equal to 0, and I have two equations to solve. So when I solve the first one, I get cosine of theta is equal to negative 1/4. And when I solve the second one, I get cosine of theta is equal to positive 1/2. Now we have to approach each of these separately and find the angles that satisfy each of these equations. But I'm going to start with cosine of theta equaling positive 1/2 because that's going to be a little bit more straightforward. And again, we're going to refer to our unit circle. So I'm looking for values on the unit circle where my cosine is 1/2. So I'll be looking for x values of positive 1/2, which again, I can identify them with a highlighter here. So I see at 60 degrees and at 300 degrees, I have a cosine value of positive 1/2. And again, I should have stated this in the beginning, but always check your directions to see if you should be working with radians or degrees. Since they want it from 0 to 360, I know that I'm working in degrees. And so I have my first two solutions at x equals 60 degrees and x equals 300 degrees. Now when we try to solve the other equation, cosine theta equals negative 1/4, if we try to use the unit circle, we'll realize that there are no values of negative 1/4 on the unit circle. So when that happens, we have to use a different approach to solving the problem. If you remember back in the beginning of the unit, we learned how to find missing angles when we knew the value of a trig function. And we did this by taking the inverse trig function of each side of the equation. So that's the approach we're going to use here. So working with cosine theta, I know it has to equal -1/4. So before I do anything with my calculator or inverse trig functions, I do want to take a moment to think about where that angle will need to be on my unit circle. So if I just draw a coordinate plane here, and I could also use my unit circle, but I'm going to use a coordinate plane, and I think about the values of cosine theta being negative, I know from the all students take calculus thing that we talked about earlier in the unit that all trig functions are positive in the first, and cosine is also positive in the fourth quadrant. So what that means is that negative cosine values are going to show up in the second and the third quadrant, which means I'm looking for angles that fall into the second and third quadrant. Now that I know where my angles should be located, I'm going to use inverse cosine to solve this equation for theta. So remember, if I take the inverse cosine of both sides of this equation, on the left side, it would cancel out my cosine. And on the right side, I would actually use my calculator. So this will get canceled out and I'll be left with theta. And on the right side, I will use my calculator to find the inverse cosine of -1/4 or -0.25. And when I type that in, I'm going to get a nice long decimal of about 104.478. I'm going to go out to the nearest thousandth, even though it does not tell me where to round to here. And so that means that my first angle that would have a cosine value of -1/4 would be at that 104.478 mark. And that 104-degree angle is going to fall somewhere about here. So you can see that that would be our second quadrant angle that we were looking for. The problem is the calculator only gave me that one answer. So where do I get my other angle that I know should fall in the third quadrant? Well, this is where reference angles become very important. So even though we can only solve for one of our angles on the calculator, we can use the reference angle for 104.478 degrees and figure out what other angle in the third quadrant has the same reference angle, because that means it would have the same cosine value. So my first step is to figure out what is the reference angle for this angle that we just found. So remember, the reference angle will be the angle formed from the terminal side of our angle to the x-axis. So that's this part I just showed in green. So I'm looking for that value, which would make sense to find that by subtracting 180 minus my angle. When I subtract, it gives me a value of about 75.522 degrees, which means that that is the size of my reference angle. So now I need to take that same reference angle of 75.522 degrees and figure out what angle in the third quadrant would have that reference angle. So what that means is that I'm taking this 75.522 degrees and extending that far past my x-axis, which means that my angle would now be down here in the third quadrant. And if this is a 75.522 degree reference angle, what I then need to figure out is what is the size of this entire angle from the positive x-axis all the way down to the terminal side of this reference angle. And so that would give me 180 plus 75.522 degrees, which would give me an angle of 255.522 degrees. So that would be my fourth and final value of theta that would satisfy this equation. So as you can see, when working with trig equations that have values that are not on the unit circle, there's definitely more work involved. Here's a problem for you to try on your own. I would recommend using the unit circle when working through it. Go ahead and pause the video now because I'll be showing the solution to this "Do Try It" in just a few seconds. You can see after solving for sine of x, I found that it had to equal positive or -1/2. which means after finding those values where sine was 1, positive and negative 1/2 on the unit circle, I came up with these 4 angles as my solution. That's all for this lesson. Have a great day.